Good afternoon. And yes, my name is Degioanni. I'm the CEO of Sysdig. I have quite a bit of history in open source, including having had a company before, which was the commercial entity behind a very popular network analyzer called Wireshark. So I've done this kind of stuff for now more than 15 years. In this talk, I'm going to entertain you with a wide variety of subjects. We're going to talk about monitoring, then we're going to talk about troubleshooting, then monitoring, then troubleshooting, and then a bit of monitoring and also a bit of troubleshooting. That's what I do. But let's start from Kubernetes. OK, so everybody here, I'm sure, loves Kubernetes. It's great. That's one of the reasons why we're here. So it's simple, scalable, isolated, service-oriented, and so on and so forth. But it's also a reality that as things evolve, as we move toward microservices, as we start adopting containers, as we start using technologies like CoreOS or Kubernetes, things become more complicated, right? This is a super simplified diagram of what an application used to be, right? Something like, I don't know, 3 components: a cache, a web server, a database. Things nowadays look a bit more like this, right? So you have a bunch of services. They are not only interacting with each other, but typically they are decomposed in units, containers nowadays that live on different machines and can move around. So not only there's like this distribution of computing and functional elements, but they also tend to interact with each other in arbitrary ways, which especially from the visibility and troubleshooting point of view makes things more challenging. It's not as bad as this, but definitely more challenging than what it was in the past. More complexity requires great monitoring, especially when we want to bring this complexity to production. So for sure, one of the things that we're hearing a lot in the community is one of the potential roadblockers in adopting all of these new and super nice technologies in production is the need of trying to improve monitoring and bring it up to speed. So we need monitoring that is isolated, automated, orchestration-aware, simple, scalable. So from one point of view, it's like we need, again, what we used to have before in terms of monitoring. And containers and distributed infrastructures make more complicated to achieve and to obtain. But we also maybe have an opportunity to make monitoring better, right? Because orchestration technologies like Kubernetes can actually be leveraged maybe to improve and maybe reinvent monitoring to make it better. So I was trying to think about ways to call this, so maybe service-oriented monitoring. And then after 2 days at this conference, I was like, OK, GIMFI. Google infrastructure monitoring for everybody else, right? We have some ideas, both in the open source world and as a commercial product as Sysdig. But maybe let's start from what's available today. What do we have today to monitor a Kubernetes-based infrastructure? Well, for sure, the Kubernetes UI, which is a good catalog of what's running inside the Kubernetes cluster. So can definitely be used at least for high-level visibility on what's running at a specific moment of time. There's a CAdvisor from Google. CAdvisor is nice because it offers both the ability of doing local monitoring through by exporting a user interface. You deploy the CAdvisor container, and then you can connect to it with a web browser. But you can also connect it to stuff like Hipster to collect these metrics and bring them to centralized collectors, for example, Kubedash or, for example, Grafana. So these are all great tools, very useful. But there are still many questions to be answered that it's not possible to answer yet with these tools. I have some examples here, but what's the network activity of, of inside my namespace? What transactions is my Redis service serving? What's using the CPU in the WordPress pod? What's the response time of a service? In a general way, where are the bottlenecks? What's really more complicated from the monitoring point of view in a distributed service-based infrastructure is identified where time is spent and where the bottleneck is, right? So let's start maybe from the troubleshooting. This is a slide from Brendan Gregg, who's great at low-level troubleshooting. And typically, when you have a problem, this slide is a great starting point because you have the different components in the levels in the stack, and there's essentially a command line tool suggestion for all of these options in the stack. So the only problem is that most of these options either don't work at all or are challenging to use in a container-based environment, let alone in a distributed environment like a Kubernetes cluster. For example, I have here, my virtual machine running a small Kubernetes cluster with a bunch of containers, and top shows me essentially the processes and what's running inside the containers. But it's like just a long list of processes. I don't really have any concept of hierarchy and segmentation of these resources. I can, in top, for example, click F and select C groups. And as you can see, this adds a column on the right of the screen where I can see the specific C groups. So if two processes have the same C groups entry, which is quite long, as you can see, it means that they belong to the same container. So I can sort of trace back things belonging to a specific container, but as you can see, it's not really useful. The other option, of course, is logging to the container or to the pod, so attaching it or running a shell or stuff like that, which is not really always doable and definitely not the best solution for something like that. So we try to solve the problem with an open source tool that we call Sysdig. Sysdig is a tool to capture system events, filter them, and then manipulate them through scripts. I typically compare it to strace plus TCP dump plus LSOF plus htop with Lua, which probably makes you even more confused about what it is. I will give you a relatively extensive demo later, so hopefully this will come together. But it's like trying to get the best of our tools and unify it in a single user interface that can be used both live to analyze the live system, but also to capture trace file the same way you would do with something like TCP dump of Wireshark, which is where the warware comes from. And of course, we try to put a nice UI on top of that. The design goals of Sysdig being production ready, which means simple and lightweight. So you should be able to use it, in a production environment, including a machine running multiple pods, and you should be barely able to see the overhead of this running. Rich set of data, instant value, natural workflow, native support for containers, and especially, and we announced this just a couple of weeks ago, native support for Kubernetes. So this is, as far as I know, the first troubleshooting tool that is fully Kubernetes aware. And again, I will show you later what it means. Before showing you that, let me spend a couple of minutes just describing how it works and how it accomplishes this. This is a simplified diagram with essentially the red box is a machine, and we have a couple of, let's say, containers running on that machine. Sysdig is deployed as a container or can be deployed as an application running in the host. But it's able to essentially leverage namespaces and C groups to be able to sort of get a view inside the other containers. So let's suppose in this machine there are another couple of containers running, like HAProxy and Mongo. Sysdig is able to detect these containers, but also see inside these containers. So another container appears on that machine. It appears on the Sysdig user interface, and you don't have to do anything to essentially discover it and investigate inside it. How does it work? So this is a simplified diagram of the machine, and we have the kernel, and as we know, the containers share essentially the same kernel on the machine. So what we do is we inject a little kernel module in the kernel. This is transparent, and it's done by the Sysdig container when it's loaded, if you deploy Sysdig as a container. And then essentially, this little kernel module is able to instrument the operating system and collect information in a couple of different points in the operating system, and in particular at the system call entry and exit point, which means that we're able to capture network I/O, storage, inter-process communication, new processes, and all of this kind of stuff. This data is collected. It's piped to the Sysdig container. In this case, Sysdig is run inside the container. And you can do analysis, collection scripts, and whatever you want. All right, enough slides. And let's go back to my machine. First of all, is this readable? Can everybody see the screen, or should I increase the font size? All right, good. So the simplest way to run Sysdig is just invoking it. And as you can see, I have an extremely verbose trace which shows the whole activity inside the system that the different processes are doing. So I can see the process name, PIDs, and the exact operation that they are doing. So as you can see, a lot of information and pretty verbose. And this would be the end of my demo. Thank you. Actually, this is just to show you the basic of the information, but this information can be tapped into and leveraged in a couple of different ways. First of all, you can run scripts like we call them chisels. One of the scripts, for example, is top containers net. So we can look at the list of containers based on the network traffic that they are generating. So as you can see, this is a bit more digestible for the typical use case. But we also have a courses user interface, which can be used for essentially real-time analysis and offers a functionality similar to top. Right? I showed you top before, and this wants to mimic actually HTOP, which is a tool that I'm a developer myself. I use it every day, and I love. So it's not random that the color scheme and the look and feel is similar to HTOP. Even the key combinations, if possible, are similar to the ones of HTOP. So if you're Unix user and any HTOP user, you should be familiar with this. On the other hand, there are some key differences here. One of them is that this is container aware. So as you can see, I have a column that I can even sort based on this column. And that lets me essentially see what are the different containers and what container a process belongs to. So I have this kind of view of the machine, but I also see the processes that are running inside the container, and I can attribute them to the proper container. There are other let me actually switch to a trace file. There are other nice things that you can do with this. One of them is opening trace files. So I can save the data exactly as I would do with TCP dump, but the data is the whole system data, and not just network data like what TCP dump and Wireshark would do. This means that, for example, here I took a capture of my system while it was generating activity. I have a WordPress service here on this machine, so I have a few pods implementing this service, and I took a trace file, and now I can troubleshoot this offline without having to be in front of the screen while something is happening. So I was talking about the differences between these and stuff like top or HTOP. Another difference is that this is view-based. So this is the basic view, the starting view, and this process list, but I can click on views or on F2, and I get my list of views. And for example, I can pick something like, I don't know, containers. And now I see the list of containers running on this machine. And for each container, I can see CPU utilization, number of processes, number of threads, memory usage, file I/O, network I/O. So it's essentially the same information, but grouped in a way that is useful if you're doing container level troubleshooting. I see the ID of the container, I see the image, I see the name, and so on. Still, when you're running Kubernetes, this is useful, definitely an improvement, but still not ideal because, this is typical Kubernetes, a bunch of containers with very long names that include UUIDs and are difficult to logically attribute to your Kubernetes structure. what we added a couple of weeks ago is the ability for this tool to query the Kubernetes API, if you're running this on a host that is running Kubernetes, to extract metadata and use it to present this information. So if I go back to views, now I can do something like Kubernetes pods, for example. And this is the list of pods. And as you can see from the name, it's much more clear and intuitive what these pods are doing, right? So this is done by taking the containers, collecting the information the way I explained before, and from one side, and from the other side, reading the Kubernetes API and the Watch API, putting things together so that this can be reported in this way. I have several other Kubernetes views, as you can see, services, namespaces, and so on. Let me go to the replication controllers one, because here I can clearly see essentially that I have 3 replication controllers, a WordPress one, a MySQL one, and a client one. Another difference between these and HTOP is this supports drill down. So I can move around, I make a selection, I highlight something, I click on enter. So for example, let me go back. I show it to you again. I select WordPress, I click on the WordPress replication controller, and now I'm looking at the pods inside that replication controller. So it's 3 pods implementing the WordPress replication controller. And here I'm seeing these 3 pods, right? I can keep going. So I can click on the first one, and now I see the containers. There's 1 container inside this pod. Want to go inside? Well, you know how to do it. Click enter, and now we see the processes inside this container. Want to keep going? Click enter, and now we are inside the specific process, and let's look, for example, at the network connections. And we're seeing, that this process is making some MySQL connections, and it's an Apache process, of course, so it's also serving HTTP connections, right? Want to go deeper? We have a functionality which is called echo. So I do it through F5. I'm doing it with the mouse here, but when I do that, the Sysdig takes the selection that I've highlighted and looks at all of the I/O activity and prints it for me on screen. Let's use the printable ASCII. And so here I've selected a specific connection, and as you can see, I can see the requests and the responses for this specific connection. So we went from a full machine to replication controllers, to pods, to containers, to a process, to a connection, to the request inside the connection through this pretty natural drill down process. So this is an example of what you can do with this tool. And of course, we can also look at the same connection, but this time dig inside it. And this is, the activity on this specific connection in all of its glory. So as you can see, I can see the accept that the Apache process did on this connection, the socket setup, the read and write, and everything else. So quite a bit of granularity. You don't even need to come to this level of granularity, but as you can see, this is pretty useful, especially because it tends to save you from having to log into the container to do a lot of this troubleshooting, and gives you a pretty nice structure to work around. Of course, I showed you network level activity, but if I go back to my controllers, replication controllers level, I can also do stuff like file I/O, for example. So if I go to WordPress and I go inside again, I can pick the top directories, for example. And these are, in terms of bytes, read, written, or in terms of IOPS or errors or file errors, the top directories in this full namespace. So we take the different containers that are in this namespace, we inspect what they are doing in terms of file I/O, and then we're able to group this for the whole namespace. For the whole replication controller. And then I can drill down again, so I can pick a specific directory, and I can click enter, and I see the files, and I can pick a specific file, like the first one, and again, echo it, and I see the reads and writes on this specific file. So I can actually see the content that has been read or written to this file. All right? Does it make sense? One more thing, actually. Let me go live again. And I want to show you, is this live? Yes. And I want to show you another feature that I find it's I find to be pretty cool. We included it in the tool pretty recently as well. So now, as you can see, stuff is moving. So I'm not on a trace file anymore. I'm on the real system. And let me go to replication controllers again. And let me go inside the WordPress one. So now I see the same pods, but this time I see their activity live, right? So like their CPU is changing. We introduced actions. So another thing that probably, especially when you develop application based on Kubernetes and you're interacting with them, it's more like an interactive process. So we didn't just want to give you a window on it, but we wanted to give you also something that is like a mix between visibility and controlling and being able to take action. So we implemented hotkeys. So hotkeys depend on what you've selected. So for example, here I'm seeing pods, and I can select a pod. And for pods, I have a number of things that I can do. One of the cool ones that I want to show you is, one is if I click F, I'm following the logs for this specific pod. So I'm seeing essentially in real time what this pod is emitting in terms of pods, in terms of logs, as it's receiving requests from the clients, essentially. And of course, I can do it for any pod. Similarly, when I select a pod, I can click on B, and B gives me a bash shell inside that pod. So now I'm inside, and I can do whatever I want. This leverages essentially, by the way, this is open source, it's on GitHub, but it's completely configurable. So you can go edit a file, and essentially what you can do is match a key press with the selection, and then you're able to create a command line. So this calls kubectl, for example. So you can really create the ones that you want. But yeah, as you can see now, I'm inside the pod. I can go back to Sysdig, select another one, and keep going. All right? So this is Sysdig, open source, fully available. It's great. Typically, when I reach this point in my demo, people ask me, OK, fantastic, but what about multiple machine? What about when I want to take a look at my whole cluster? This is perfect when I want to go very deep. So when you want to see a whole cluster, what we have is Sysdig Cloud. So Sysdig Cloud works on with the same technology, instruments in the same way, so as similarly rich set of data. But this time, instead of having something that gives you a console on the same machine, the data is collected by a container on each physical machine or virtual machine running the containers, and it's piped to a centralized backend. Let me actually see if I have network. Oh, perfect. Yes, I do. So this is the user interface. As you can see, it's a web-based user interface. The data is collected, and then it's exposed through a web UI. Here, for example, we are seeing a small Kubernetes cluster made up of 4 nodes. We have a master and then 3 minions, right? So I can expand these and go look at one of my 3 minions and see what's inside and see the specific containers that are running inside this machine. And of course, I can map the CPU for a specific container, for the machine, or even for a group of machines, okay? But what's interesting is typically the problem with something like that is something like this is services are implemented by multiple pods, which run typically multiple containers, which are living in multiple machines, right? So seeing things at the physical level is useful for like capacity planning and so on, but typically when you're thinking about this from the application and from the service point of view, it's not so useful. So what we do is we, again, consume the Kubernetes API so that we're able to locate around your infrastructure the containers that implement maybe a specific service or a specific namespace or whatever you want, and put them together to give you a view that is more like at the cluster level. What that means in practice is that, for example, I can change my grouping, and I can use a grouping that is something like namespace, replication controller, pod, and container. And as you can see, this makes more sense. I see a dev namespace and the production namespace. I can expand the production one. I can see what's inside in terms of pods, and I can go down to the specific, containers that implement this specific service, which also means that I can monitor, for example, let's pick WordPress, and let's do something like HTTP. Oops. So now what we're seeing here is the response time, number of requests for the specific, for the WordPress service that I had selected, status codes and so on. So again, how does this work? There are multiple containers here. They serve HTTP requests. We look at the metrics in terms of slow URLs, response codes, and this kind of stuff by decoding the traffic, by looking at the traffic that all of these containers are doing. And then we take this information and we put it together by following essentially the hierarchy of Kubernetes. This is, one of the several things that can be done here. One other cool thing that I want to show you is the ability to essentially trace and reconstruct topologies. So again, I typically compare this to Google Maps for your infrastructure. So what happens is we use the same technology, we capture the network interactions that all of these containers are doing, and then we are able to group them hierarchically so that we are able to give you a real-time, 1-second granularity map that shows essentially your Kubernetes cluster. So here we're seeing the master and the 3 minions, and I can use my mouse to zoom in, and as you can see, I start seeing the machines inside the minion group, and then I keep zooming and see the containers inside these machines. So pretty cool, right? The problem is, again, this is managed by an orchestrator which puts containers in arbitrary machines. So as you can see, the diagram is sort of confused. There are 2 services running here. If you follow the lines, you can see where they're going, but it's not completely straightforward to understand what happens. But what if we take the same representation, but this time we essentially group it by using Kubernetes namespaces, replication controllers, pods, and so on. As you can see, much more clear. We can see the same structure that we were seeing before. So, the developer namespace, a production namespace, the kube system, and so on. Let's zoom into production. This time, as you can see, my topology is much more straightforward, and I can see now the 2 services. I can see the WordPress service with clients, WordPress, which is for pods, and then MySQL, and then I can see a Java service with a client, an application which is for pods, and Cassandra, Mongo, and Redis. Keep zooming, and I start seeing, the replication controller dispatching this traffic to the pods. Keep zooming, and I can see the containers inside the pods. Keep zooming, and I can go down to this process and look at what Tomcat is doing, and the traffic that is receiving, and the fact that he's talking to the next tiers. So again, similar to Google Maps for your infrastructure and completely dynamically generated. I hope this gives you an idea of what can be accomplished here. You find more information online. You can download Sysdig from our website, or you can go and compile it yourself on GitHub. You find more information on our website. And we have a booth downstairs. So if you're interested in having more information or get a more in-depth demo, feel free. We're always happy to talk to people. Excellent. 1 minute and 12 seconds to go. So pretty good.
I have to say, it's not often that you run into a piece of open source software that is so full-featured, and at the same time, the kind of commercial or cloud application of it is such a compelling thing that you look at it and very clearly go, much like in Napoleon Dynamite, I want that. And this is a perfect case of that. Like that demo of being able to show that, like at the cloud level, drilling all the way down to the process level into a pod is a perfect case of that. So thank you, Lawrence.
Thank you.
That's absolutely fantastic.
And thank you all.